Hello, everyone, and welcome. My name is Sarah, and today we're bringing you another webinar in our ongoing series using the all-new Dynaform 6.1. We have attendees joining us from all around the world, and we appreciate everyone taking the time to join us here today. For over 38 years, ETA has been the leading provider in engineering software solutions to clients and customers around the world. Your webinar host today will be Jensen Chen, the VP of Global Sales and Marketing Dynaform. Jensen has over 20 years of experience using LS Dyna and Dynaform. Jensen's co-host Ming Zhang is a senior project engineer and lead Dynaform support here at ETA. During the presentation, if you have any questions, please type them in the Q&A section and a Dynaform team member will reply to them as quickly as possible. We will also have time for questions at the end of the webinar. And the last thing before we get started today, there will be a short poll at the end of the presentation. If everyone could take a moment to fill it out, it would be greatly appreciated. Without further ado, I will turn it over to Jensen and Ming.
All right, thank you very much, Sarah. Good morning, good afternoon, and good evening to all of you. I hope everyone is doing well at this time. Thank you for taking your time to join our webinar, Accelerating Blank Cost Estimation by Utilizing Blank Size Engineering, which is BSE module. My name is Ming Zhang. I'm the Dynaform support lead for North America. Today, I will be present and demonstrate the capability of assembly BSE for blank cost estimation. So during the presentation, please feel free to type your questions while the QA message box at the bottom from Zoom. And as my colleagues, Mohsin and Curtis, will be available to answer your questions. Okay, so let's start. Actually, we have conducted a webinar about the blank cost estimation and the sheet metal stamping simulation in the past. For those who missed these webinars, please feel free to visit our YouTube channel, ETA Info 1, to view the recording. Let's take a look at the outlines of today's webinar. I will briefly cover the ETA's corporate profile, Dynaform background and the modules. And next quick overview of accelerating blank cost estimation using assembly BSE. I will continue to conduct a live demo today, following by polling and Q&A session. Okay. ETA was established in 1983 by a group of engineers. We have been serving the automotive industry in the past 38 years as an advanced engineering service supplier that has supported over 40 plus vehicles program. We have over 300 employees worldwide. We are also the software developer of ACP Op Design, VPG Suite, Dynaform, and the Presys. Dynaform is our flagship product for sheet metal stamping. It started as a small code developed by Ford Motor in 1983. The first version was released in 1996 with Dyna as the core engine for predicting metal stamping deformation characteristic. Over the past 3 decades, multiple versions were released with many new technologies for solving sheet metal stamping problems. We have released the version 6.1 a month ago. The market spectrum of Dynaform ranges from aerospace, automotive, motorcycle, electrical, consuming electronics industries. Basically, any industry that involves the sheet metal stamping is a Dynaform's potential target. Okay. Dynaform consists of 6 distinctive modules. Blank size engineering is used to quickly perform blank material cost estimation, as well as improving blank material utilization rate. Formability, which is FS module, is aimed to deep drawing, progressive die, and line die stamping simulation. It helps to improve tool making cycle time by solving stamping defects prior to constructing the actual tools. Die evaluation is utilized to quickly evaluate draw die design, trim line, and also the scrap size. For die structure, scrap flow, and the sheet metal transfer, the die system analysis module can be employed to investigate various die system related problems such as die structure fatigue, scrap blockage, and interference during the sheet metal transfer process. Dynaform also consists of a blank and trim line development module, which is utilized to conduct a near net shape simulation of a prediction of a blank outline and a trim line using iterative optimization approach. With all the features, Dynaform helps to reduce product development cycle time and improve profitability. Now let's look at today's topic. I will demonstrate the setup of review the simple step of setting up a blank cost estimation using BSE, and then I will present several examples using assembly BSE. It will help to speed up the blank cost estimation process for large assembly modules. This assembly BSE is an automatic blank cost estimation process, which can quickly unfold the part geometry and perform blank nesting. And at the end of the process, a report is automatically generated in Excel format. Our past exercises indicated that the assembly BSE helped to reduce the total time spent of creating blank cost estimation of large assembly a lot. It could reduce 90% of the time. Okay, so then I will start my live demo. So in today's demo, we have totally 3 cases. The first case, it will be a real bumper with the surface. And next case will be a roof enforcement part with a solid model. And the last one will be an underbody assembly, which is a very large assembly. Okay. So now we will, start with this new project, which is a real bumper. Then I'll just go ahead and define the new project like a name, directory, and move with this blank size engineering. So instead of running outline and the formability and nesting, we have covered that in the previous webinar. So this time we'll be running this assembly BSE. So I just created this new assembly BSE project. So now, as you can see, this window is called a part list. All the parts in the assembly will be imported into this list. But before we do that, I want to talk about a little bit about this setting. So in the geometry, we already know for this case, we are going to use a surface. We are not going to use solid. So make sure we select the right option. So we'll be using the surface. And for the material and thickness, there are 2 ways to define them. One way is to read the material and thickness from Excel file from a table. This can be done, this file can be transferred from a BOM file. And also we can define the material and thickness by read them from the CAD data. We will show that feature in the next example. So for this example, we will be using this table. We will read the information from a file. So actually in this Excel file, I do have the material and thickness information. Also for nesting, we could set up the parameters by auto or from table or even no edge and bridge. And later we can generate the report. Here is a tab for us to control the report we want. And also we are able to customize our report by clicking this. Then I will just pick up the item I want to add to my report and then add each of them to this mapped view. Okay, so in this case, I already imported the material and thickness information. Now what I need to do is just import the geometry. So we do support all the major CAD format like a TIA, NX, SolidWorks, Parasolid, not only the part and also the assembly. Also, we do support the general universal format like IGS stat file. So in this case, I only need to select the assembly part file from the next. So and then just open it. It will just take a few seconds to import the whole assembly. Not a lot of parts in this assembly. As you can see, totally we have 5 parts here, and the material and thickness they are already defined. And also we can easily hide and show the model, and also hide and show each individual part. If you click on the part on the screen, it will automatically locate your part from the part list. And then actually this model is already ready to run. I will just go ahead and submit it. It will immediately start to running the unfolding and nesting for each part. There's no pause or stop between the parts. Um, Also, from under this part list window, you can see the import and delete. That means later, once we finish or before we run this assembly BSE, we can add more parts or delete current parts. And also, if I don't have a Excel file which contain the material and thickness information, I can also manually define them one by one. I'll go to this default material and thickness to define them in a batch mode. And also, there's one option here called the submit option. This will allow you to submit a certain group, a number of parts as a group. Then when they finish it, they will pause and wait until you click submit again and run the further parts. So this which will be very helpful when you run a super large assembly, which could contain 100 and 200 parts. You don't want you know once you started, you cannot stop between. So uh, you can run like 50 at one time. As you can see, it's running pretty fast. It uses the one-step solver. Um, Currently, we already finished 3 parts here. So just give it a few seconds. It will finish all of them. So on the screen, it print out the part shape and the nesting result. So now we are running the last one. It will be done just in a few seconds. Okay, so now all the parts they're finished. Now, as you can see on my screen, the status for all the parts, they are all showing finished. And the software actually is working on the report now. So once it's done, now let me resize it. So now on my screen, this is the assembly BSE report. So we do have the basic information at the left, like a part number, part name, part size, the dimensions, and thickness, blank size. And also on the right hand, we have 4 method nesting result, which are one up, two pair, and the mirror. Also, you can see the utilization values here. Okay. So actually, this is the my first case. So now for the second one, I'll be showing you to read the material and thickness in a different way. Okay. So second project, I will very similar to the case one. So I will define the project name, define the working directory, and then select the blank size engineering, and then continue. So also we will move on with the assembly BSE. So in this case, I'll be using solid instead of surfaces. And also the reference geometry will be top or bottom surface. So for the material, also it will be read from the part geometry. Okay, so nesting report for nesting and report, I will just leave them default. Now I need to go ahead and define import our geometry. I can just select this solid assembly file. So for saving time, I already have it opened. So I'll just uh, open the file. It's already done, the importing. Okay, once you import the geometry like this, then you will see the thickness that automatically read from the CAD data. Okay, so you don't need to define them now. But for the material, we don't have any Excel file or table file. We have to define them uh, manually. Uh, One way is I can just click on the part and select them from our material library or import the material file, or I can use this default material and thickness function, just giving one material for all the parts here. Okay, once this is done, I can submit the job just like the case one. I will not submit now. This will take a little bit longer time than the case one. It will take 3-4 minutes for saving our time. I already have the result here. Okay, in this file, everything is finished. So very similarly, I can just view the result by opening the report file. For example, for this number, part number 4, a very small bracket. We have 2 holes here. Then we read all the information from the file. What if I want to modify one file in a big assembly? What I can do is I can go here and just click on this view, find this bracket, and then once I click on this view, it will go into the BSE module for this part. So actually, this is very, very similar to this is the same module we use for BSE, basic BSE and advanced BSE. Since we already covered all the topic in our previous webinar, we are going to not spend too much time on each of these items. But if you need information, you can go back to to our YouTube channel. Okay, but some modification I want to make to this part. Maybe I want to fill these holes here. So actually what I can do is I can just recognize these holes and quickly fill them here. Now the next step, I need to update all this information for both unfolding and nesting. So as you can see, they are red. They need to be updated. I can go here and update them one by one, or I can just make one click on here with this update all button. Then all the unfolding nesting result will be updated. So once it's finished, you can see, okay, on the flat sheet, there's no holes anymore. And then with one click on this update report, also the report will be updated. I already have the updated report open here. So now as you can see, the new report, there's no holes on this part anymore. Okay, but for the other part, they will still use a previous result. Okay, so that's pretty much about the case 2. Let's look at the next case, which will be a full assembly of Underbody. This is a very large model. Today, we are not going to run anything on this model because it takes a very long time. But I will share my story with this model. This full assembly contains about 140 parts. They are all solid parts. The model is in solid. So when I import the geometry, it will read all the thickness automatically. Then I just assign some material for all the parts. Then this full assembly took me about 1 hour and 15 minutes to run on my laptop. So once it's finished, and then I also get this full report. Okay, this is a very long report for the full assembly. Also, some part is they cannot complete the BSE because they are not stamping part. Some of them are bolt or screws, fastener parts. Okay, so actually, if I do this BSE part by part using the traditional way, it will take me about 2 days to finish them. But with this assembly BSE, it's fully finished in just 2 hours, within 2 hours. So it will save me like 90% of the time. All right. Okay, so I think that's pretty much about today's demo. if you have any question, please type them in the QA box. I think our demo and our example are very straightforward. Um, this new BSE is very easy to use and with a very high efficiency and save a lot of cost on time. Okay, and also I will launch a polling now. So your opinion, will be appreciated. It will help us to improve our software. So I will just give 1 or 2 minutes to everyone to finish all of them. Make sure you scroll down. You finish all the questions. There are totally 4 of them. So make sure you scroll down to the bottom before you submit the polling. One question from Jimmy. Manual BSE for the underbody may take more than 2 days. Yes, correct. They may take a even longer time, 2-3 days to finish the whole BSE. But in this report, in this function assembly BSE, we can generate this full report in just within 2 hours.
Ming, I have a question.
Yes.
Any limitation to the number of parts we can?
Oh, actually, in the good question. In the assembly BSE, we do have we do not have any limitation, but we recommend the assembly less than 500 parts because the larger the model is, the slower it will be. So for the best performance, we suggest the assembly parts contains less than 500 parts. Okay. Is there any other questions?
How about the tailor welded blank? Can it read such files?
Is there any documentation showing that it does Yes, we will share this information later on the YouTube channel and also through our email. Sorry, Mosin, what's your question?
Can it read the tailor welded blank information and do the BSE?
Yes. Actually, if the tailor weld parts they are defined by different part ID, then the software can recognize them and do the run the unfolding and nesting by parts. They will not recognize them as one.
Thanks.
One question I see from here: how are you unfolding? It is one step. It is one step solver. It's called MStep. It's developed by ETA, and it will unfold the part. It's not an incremental solve. Okay. Is there any other questions? No further questions. Okay. I think that's it. I will just give the time back to Sarah.
All right. Thank you, Ming. Hello again, everyone. We hope you enjoyed today's webinar and found it informative. We will be uploading a recording of this webinar to our website and our YouTube pages soon. Please keep a lookout for our next webinar in the series where we'll be discovering blank and trimline development for near net shape blank estimation. If you have any questions or would like more information, do not hesitate to contact our Dynaform team. They will be able to help you with anything you may need. And once again, thank you for joining us. Have a great day and stay safe.
Thank you, guys. Bye-bye.